Hi, I'm Sophie and I'm an undergraduate student in Dr. Sheardown's lab this summer. Today we're going to be exploring density using ice cubes that have been dyed with food coloring, tap water, and some salt. So since today's experiment is going to be discussing density, I first wanted to begin with a bit of a discussion about what density is and show you guys a couple of examples to help better explain and demonstrate how density relates to our everyday life. So here I have a brick and a pillow. We would say that our brick is more dense than our pillow. This is because our brick is a lot heavier, it has a lot more mass, and it takes up a lot less space. It has a smaller volume than our pillow. A pillow is a lot lighter, so it has less mass and takes up more space, so it has a greater volume. So, as I've exemplified with our brick and our pillow, density is the relationship between mass and volume. An object like the brick, which has a greater mass and a smaller volume, has a greater density. This means that our brick, if you were to toss it into the ocean, would sink to the bottom because it is a lot more dense than the water in the ocean. Then, if you were to take your pillow with its little mass and big volume and put it in the ocean, it would probably float. This is because it is less dense than the water in the ocean. So, as you can see here, I have my two glasses, both filled with room temperature tap water, and I also have my salt. Into one glass, I'm going to add a lot of salt, so much that it no longer dissolves. And you're going to have to give it a stir as well. It might take a couple minutes to make sure that your solution is super saturated, so that there's more salt in the water than can be dissolved. And there we go, that's looking good. So the next thing we're going to do is take one of our ice cubes and we're going to gently place it into each glass. So there's the one with the salt, and there's the one without the salt. And the first thing we'll discuss is why the ice cubes float on water. Intuitively, you would think that a solid would sink in a liquid, but with water, it's pretty interesting because when water freezes, the molecules that make up the water align and become what's called a regular lattice. And this lattice, because it's more uniform, the molecules spread out a bit more, and the ice actually is less dense than the water, which allows the ice to float on top of the water. Now, as you can see in the two different glasses, you have two very different things going on. In this glass, you'll see that the darker water coming off of the ice cube is actually sinking to the bottom. And this is because the cold water is more dense. The molecules are more packed together. The more packed together molecules then go to the bottom because it's more dense and push the warmer water up, which is also why your ice cube in the fresh water will melt faster than the one in the salt water. Then, here in the salt water, you can see that there is a layer of the blue water forming on top of the salt water. Instead of the ice cube melting and the fresh water from the ice cube pushing down through the salt water, it's staying on top. This is because the salt water, because it has a salt, it has more molecules in it, it's way more dense than the fresh water, which means that our fresh water wants to stay on top because it's less dense. Because of that, we have these two distinct layers, and the ice cube is surrounded by the colder layer of water, meaning that it melts a lot more slowly. As you can see, if you look over top, the ice cube in the salt water is a lot larger than the ice cube in the fresh water here. Eventually, if you wait long enough, you'll see after both ice cubes melt, you're gonna have one uniform colored water container, and that's the one with the fresh water, and you're still gonna have a layer of the more dense salt water on the bottom, and then our ice cube that's melted, that's the fresh water on the top. And that's why an ice cube in fresh water will melt a lot more quickly than an ice cube in salt water. Feel free to leave any questions or comments in the description below, and I'll be sure to get back to you guys. Thanks.